All right, pre-calc 11ers. Here we go. Little shout out to my number one fan, Aphrodite. Have a good day. Here we go. We're going to do angles in standard position. We've done trig in theory of sine law and cosine law, which deals with kind of fairly down-to-earth triangle situations that you'd use in architecture and forestry and any kind of building process, things that are very visual. Now we're going to get into more of a abstract trig in the sense of things, which is used in engineering as well, but it's not as, you don't see this as apparent in the world right in front of your eyes. So we're going to do angles, and it's called angles in standard position. It is actually the first section of the chapter 2, so 2.1, page 83, 1 to 7. So we're going to go through a few definitions, and actually this is quite a, I'm not going to say simple lesson, but in my opinion, once you understand this is actually quite a quick practice to get through and just understand the terminology. So let's talk about what the definition is. So to draw an angle, so we're kind of getting away from triangles a little bit, although they'll come back into play. So if you have an angle in standard position, how that is drawn, people around the world had to be able to talk about angles, and they had to have some kind of standard way of just talking about them, so they decided to put them onto an XY plane. And I'll show you how they would do that. So let's get rid of this too so it doesn't look so overwhelming. So if I drew an XY plane, a coordinate plane, and if I was to draw an angle in standard position, what you would do, it's like having a clock, except for you start on the positive x-axis, and that arm, if you want, think of that, like I said, almost like a clock hand. That's called your initial arm. Sometimes they call it the initial ray, because a ray is kind of a half a line that starts at one point and goes forever this way. And then if you think of this spinning, just like a clock, if I was to spin or flick this arrow and it would move to another location, so it would rotate about the origin, this angle would be the rotation that we're speaking of. Where this arm ends is called your terminal arm. Terminal meaning end, so terminal. And this angle here, whatever it might be, like for example, if I spun it from here up to there, that'd be 90. So this is somewhere between 0 and 90. So I'm just going to estimate maybe it's like 47 degrees. But I could grab a protractor and do it exact, but we're just getting kind of ballpark. So that would be the definition of an angle in standard position. So a few things to take note of. The initial arm is always the positive x-axis. One thing that is important to take note of, when you're spinning, when you spin counterclockwise, let's do that first. So this is, I spun counterclockwise here, opposite the way a clock would spin. That is considered a positive angle. If you actually spin the other direction, clockwise, it actually is a negative angle. So math people had to have a way to differentiate between the two, and they went with counterclockwise positive angle, clockwise negative angle. And your terminal arm can end up being in one of these four quadrants. And this is considered quadrant 1, this is considered quadrant 2, quadrant 3, quadrant 4. So that's kind of just the terminology. So now they're going to ask you to draw these. They'll say draw these angles in standard position. And you just have to remember these little rules. Not even so much rules, just that's the guidelines that are globally used. So here we go. Here's a bunch of angles. Draw the following angles in standard position and state the terminal arm quadrant. So if I was to draw 210 degrees in standard position, as soon as I see standard position, I am right away drawing my XY plane, starting here in my mind. There's my initial arm. As I spin, first of all, this is positive. So positive spin means I'm going counterclockwise. So I'm going to spin around, and you just have to kind of gauge it. I could get a protractor, but I'm going to kind of go around and just think about this. So if I was to spin to here, that would be 90 degrees. If I kept spinning right to there, I've done 180 degrees. And then if I went all the way to here, that would be another 90. That would be 270. That'd be too far. So just remember, this is 90, this is 180, this is 270, and when you come back to here, you've done a 360. So 210 is somewhere between here and here. And you can kind of estimate it. Well, 180 to 210 is 30 away, so maybe it's another little spin like that. It's somewhere in quadrant number 3. And there's your quick sketch. If I wanted to get really accurate, I could draw this with a ruler and get a protractor and actually make this here 30 degrees. So there's my drawing. There's my angle in standard position. Done. That's it. All right. And really important, you show arrows on your initial arm and your terminal arm, and show the arrow at the end of the little arc here. So then it shows the rotation. Okay, negative 72 degrees. So negative means I'm going clockwise. Draw my XY plane. Starting here always. That's just the rule of the world. And I'm going to rotate this way. Now remember, if I went this direction, this would be negative 90 degrees. Negative 72 is not this far, but it's definitely more than halfway. So it might be somewhere like there's negative 72 degrees. Done. And where did I end up in? I ended up in quadrant 4. 360 degrees. Well, XY plane, starting here, rotate 90, 180, 270, 360, and kind of almost spiral it out like a shell. And then there's 360 degrees, and notice it was positive, hence that's why I went counterclockwise. Oh, my neighbor is weed eating. Okay, D, negative 350. So negative, counter or clockwise. XY plane, starting here, rotate, negative 90, negative 180, negative 270, negative 360 would be too far, so we're gonna go close to there. There's negative 350 approximately, and this would just be a little 10-degree wedge in there if I wanted to be really accurate. But there's my sketch. 1200 degrees. How do I go about doing one like that? Well, positive first of all, going counterclockwise. Starting here, I could do this a number of ways. How I would personally do it, I could just sit here and just keep counting 90s, like 90, 180, 270, 360, blah, 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 blah. Keep adding 90, 90, 90 until I get to that number or close to it. What I personally prefer to do if it's bigger than 360, oh, there goes the garbage truck. This is an exciting day. I usually go 1200, and I would just kind of subtract 360s. So if I take away 360, that's one full spin around, and I'm left with 840. So one full spin around, there's 360. I got 840 left. Take away another 360. So that's a whole other spin around. I could just make a nice little shell spiral. Still got another 360 I could take away. So it's another whole time around. So it's 3 times around plus an additional 120. So what did we do there? We basically just showed that 1200 is 3 times 360 plus 120 more. I could do that with division too. I could actually go 1200 divided by 360, and notice that there's a full 3 spins with this 0.3, which is the 120 left over. And then to get 120, from here I'm going to go, okay, well, there's 90, and then I've got to go 30 more, so 30 more degrees-ish, about there. I end up in quadrant number 2. And there's my 1200 degree spin shown in standard position. That's why you can't draw that in a triangle, because that's way beyond the triangle size. And this one here, I didn't write it down. This was quadrant 1. Okay, last one here. 5 degrees, almost so easy it's hard. So you draw that XY plane, start here, positive, goes clockwise, or counterclockwise, sorry. And 5 degrees, just a little wedge, little wedgie right there. Done. And where did I end up in? Quadrant number 1. All right. So last thing is one last definition, is what's called the reference angle. So let me kind of highlight that, and we'll go through the last few examples, which again are fairly similar. So this is important. So the definition of a reference angle for an angle in standard position is the positive acute angle between the terminal arm and the x-axis. Now, when you first read that, like any kind of definition, it just sounds like wah, 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 wah. But let's go through an example to make sure that makes sense. So first of all, or let's analyze this first, and then we'll do an example. So the positive acute angle just means the answer is going to be positive, and acute means the answer is going to be between 0 and 90, always. And that angle will always be between the terminal arm and the x-axis. You can write out the word reference angle or you can go angle ref, or sometimes people go theta with a little super or subscript of r. Those all mean the same thing. I prefer this one personally because it's the quickest to write. But you can write any of those. That's a definition of how you would write it. So we're going to go through the exact same questions we just did on the other page, and we're going to find now the reference angle. So notice these are the exact same questions we did in the last one. So as soon as I see this, as soon as I see reference angle, the first thing I would be doing, and I'm just going to kind of port this over, I would be drawing out all those angles again. So it would be literally a carbon copy process of, I would literally do this again. So there's the quick, haven't done any reference angles yet, but I would draw the picture first. And once I have the picture, then I can find the reference angle from the definition. So if I follow this definition, it is the angle between the terminal the angle between the terminal arm and the x-axis. If you look here, here's the terminal arm. You've got the x-axis is this full line here, and you've got two choices, and this is where it's really important. You've got this angle here, or you've got this angle in here. But out of the two, the one that is acute is always the smaller one that's less than 90. It's right in here. I'm just going to shade in with my marker, which kind of got ugly. That little wedge there, that is my reference angle. And you can kind of look here just by logic. If this to here was 180, and we had to go to 210, so 210 take away 180 would give me 30 degrees. Right there, that's my reference angle, 30 degrees. It's positive, always. It's less than 90, and it's terminal arm to x-axis. Never, ever, ever go to the y-axis. Yes, this is 60 here. Good for it. Doesn't mean anything to us. It is the x-axis terminal arm answer we're looking for, always. Okay, next guy. Draw the picture. Again, so draw the right angle, proper angle. There it is. Where's my terminal arm? Here it is. Got to find the acute angle between this and the x-axis. Again, two choices. I either got this little wedge or this big wedge here, but it's always a smaller one, less than 90. This is my reference angle right there. So my reference angle, you might look at that and go, well, this is negative 72. That actual size is 72, and it's always positive. The reference angle is always positive, even if the angle itself is negative. So the reference angle here, 72. Okay? Even though I know in here, this is going to be, what, 18 degrees? Don't care. That's the y-axis. Useless. Next one. Uh-oh. Terminal arm is here, between the terminal arm and the x-axis. Well, how big is that angle between the terminal arm and its x-axis? It's 0. Or it could be 180, but that's bigger than 90. So it's going to be right there. There's nothing there. 0. Reference angle is 0. All right. Next one. Negative 350. Draw the picture. Terminal arm, x-axis. It's this guy, small little wedgie right there. And again, just by using your wit and logic, you know it would be 360 all the way around. You've only gone 350. So 360 take away 350 in your head would be 10 degrees. There's your reference angle. Notice the negative doesn't play a role. It just tells you where you are. Next guy. So here, terminal arm, x-axis. And again, I have two choices. I've got this full angle here, or that big angle there, which we knew is 120. Or I've got this angle here, but it is always the small angle. Always. So how do I find that? Well, just use logic. So you've gone all the way around. Blah, 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 blah. You know this angle is going to be between 0 and 90. You know from here to here it was 120. Okay, but from there to there, that's 90 of it. So this up here is 30, because 30 and 90 is 120. But that angle there is not the reference angle. It is this angle here. So if that's 30 and there's a 90 here, this has to be, the reference angle has to be 60 degrees. So hopefully that makes sense. It's simple, and yet it's easy to make mistakes on this. And the last one, terminal arm, x-axis. This one again is almost so easy it's hard. That is the reference angle. The reference angle is 5 degrees, where it's exactly the same as the angle given. That doesn't happen all the time, but it will happen if it's in quadrant 1. Okay, so that is the lesson. That's it. The homework again, I'll post on the assignment obviously, but just to recap, page 83, 1 to 7, and have fun with angles in standard position.